Good evening everyone. Welcome to second lecture of physics optional for UPSC CSE for the English course. Okay, and as you know that the Hindi course is also available and Marathi course is also available. The links have been given below. But right now this course is in completely English. Okay, not even a single word of Hindi will be used. Okay. So if you want the lecture to be in Hindi, the link is below in the description as well as in the form of comment. Okay, you can go over there. So see, Newton's third law of motion is the topic which we are going to cover today. And Newton's third law of motion says that to every action there is an equal and opposite reaction. Okay, even a person who does not know physics also says the same thing, that I know this very well, he says. Okay. Even if he is an art student, he is able to clearly say that I know this very well. Okay, this statement is so common that to every action there is an equal and opposite reaction. Okay, now in physics, how to understand this thing? Okay, suppose there is a wall and you have a ball. Okay, now when you hit the ball on this wall, what will happen? The ball will apply some force on this wall, and the ball will be reflected back by the wall. Okay, so let the ball be object number 1 and let the wall be object number 2. So the force exerted by the ball on this wall will be equal to F12. Okay, and whatever force the wall applies on this ball, that will be equal to F21 vector. Okay, so the physics says that whatever force 1 has applied on 2 and whatever force 2 has applied on 1, they will be equal and opposite. For example, 1 applies a force on 2 in this direction and 2 applies a force on 1 in this direction. Okay, so directions are opposite, right? As the directions are opposite, so that's why negative sign is used in order to express this law. Okay, so F12 equal to minus F21, where negative sign just shows that the directions are opposite, it's the Newton's third law of motion. Okay, but Newton's third law of motion has a limitation, that whenever we see the field concept. Okay, so the third law of motion of Newton is based on action at a point concept. Okay, so third law of motion of Newton says that as soon as the ball will hit the wall, the forces will be applied instantaneously. Okay, for example, if the ball hits the wall, then the wall will apply the force on ball at the same instant. Okay, there will be no time lag between the object number 1 applying force on object number 2 and object number 2 reacting to the force applied by object number 1. There is no time lag between the two. It's an instantaneously happening process. This is what third law of motion of Newton says. Okay, but in reality this is not always true, because in case of contact forces this is true, but in case of non-contact forces such as gravitation, this concept is not true. As if we consider a ball falling on the earth, okay, ball falling under the gravity of the earth, if we consider that, then suppose ball is object number 2 and earth is ball is object number 1 and earth is object number 2, then in this case force exerted by object number 1 means ball on 2 will be represented as F12, and the whatever force and means the reaction which earth will apply, that will be called as F21. Okay, now according to the field concept, there will be a time lag, a small time lag. Okay, a very small time lag, but there will be a time lag between 1 applying force on 2 means ball applying force on earth, and the reaction applied by earth on ball, those will have a little bit of time lag. That's what the third law of motion does not tell us. Okay, third law of motion is based on the action at a point concept, and it says that instantaneously action and reaction simultaneously they will act. Okay, without any time lag. But according to field concept, gravitational field concept, when we consider ball as object number 1 and earth as object number 2, and suppose the ball is falling, then in that case the forces are a little bit of time lag is found in between the forces, that the ball, when if we suppose that the ball applied force on earth, that is action, and force applied by earth on ball, we consider that as reaction. Okay, so these two forces are equal and opposite, but according to Newton they will act instantaneously, but according to gravitational field concept they will not act instantaneously. Okay, there will be a time lag. Okay, because this is non-contact force. Okay, gravity is a non-contact force, and the example which I gave about the wall and the ball, that was contact force example. Okay, so in case of contact forces, this action and reaction pair act simultaneously, and in case of non-contact forces there might be a time lag. Okay, there might be time lag. I am saying, I am not saying that compulsorily there will be time lag, but there might be time lag in case of non-contact forces. Got it? So this is the limitation of third law of Newton. Okay, now this negative sign just shows that the action and reaction pairs act in the opposite direction. For example, this ball and earth, the earth is pulling the ball towards its center. Okay, so if we consider that the ball is object number 1 and earth is object number 2, then obviously the earth, whatever force the earth will apply, that will be force applied by 2 on 1. Okay, 2 on 1, because earth is object number 2. So as earth is object number 2, whatever force the earth will apply on the ball, that will be F21. Okay, so this is a vector. Okay, in the downward direction towards the center of the earth, and whatever force the ball will apply on the earth, that will be upwards. Why it will be upwards? Because ball is pulling the earth towards itself, right? So ball will pull the earth towards itself, so that will be F12. Okay, and these two forces F21 and F12, those will be equal and opposite. Okay, right? Because ball is pulling earth upwards and earth is pulling ball downwards, so these two pairs will be equal and opposite, and that's why, as the direction is opposite, minus sign has been used. Magnitude will be same, but direction will be opposite. Okay, so this is clear, I hope. Now some students get confused that if the ball pulling the earth, right? If the earth is pulling the ball and the ball is pulling the earth, and both the forces you are saying that the magnitude is same, then why the effect on earth is not seen? They say like that. So see, effect on earth is not seen because earth is a very massive object. Okay, so this F12 force which the ball is applying on earth, that will produce negligible effect for the earth, because earth is very heavy. Okay, its weight in earth ka weight jo hai, earth's weight is of the order of 10 to the power 24 kg, right? Earth's weight is like that. So that's why the effect on earth is not seen, but the effect on ball is seen easily, because ball is of the order of a few grams. Okay, its mass is of the order of few grams, so that's why the effect on ball is seen, but effect on massive objects such as earth is not seen. Got it? So this is the thing. So now we will understand this remark that action and reaction never acts on the same body. What does this mean? This is very obvious, right? If we take the example of wall and ball, then what was happening? The ball applied the action on wall, and the wall applied the action on ball. So action and reaction pairs are clearly acting on the different bodies, because ball applied action on wall and wall applied reaction on ball, right? So these two are acting on the different bodies, right? This never happens that the ball hits the wall and action is applied on the wall and reaction was also applied on the wall. This never happens. Okay, because if action is applied on the wall, then reaction will be obviously on the ball. Okay, if this would have been the case that action and reaction act on the same body, then the thing is, the ball would have hit the ball would have hit the wall and it would have stuck or to the wall, okay, because reaction is not there, and all the action was also on wall and reaction was also on wall only. So in that case the ball will stick to the wall, right? So this is not the reality. That's why it is written that action and reaction never acts on the same body, right? So ball, whenever it hits the wall, the reaction will be on ball, because action was applied on wall, so reaction will be on ball, okay. So this is the thing. Similarly, in the case of object falling under the gravity of the earth, whatever this never happens, that action was applied on the earth by the ball, and so reaction was also on the ball only. This never happens, okay. So otherwise the ball will not fall, right? See, if in case this ball pulls the earth towards itself, and this is called as action, okay, and if we say that the action was applied by ball on the earth and reaction was also applied on the earth only, okay, so in that case the ball will not fall at all, because what's the need of the what's the need? The need is that whenever the ball pulls the earth towards itself, so earth will also pull the ball towards itself. It's only then that the ball will fall. If the action applied by ball on earth is in the upwards direction, and if the reaction on the earth is also in the upward direction, then the ball won't fall at all, right? It will keep hanging in the air, okay, because earth didn't apply a force on it. Reaction was never applied by the earth, so ball will keep flying. So that's why action and reaction never act on the same body has been written. This is a very simple concept, okay. So remarks are here. So in the next class we will see the frames of reference, inertial frame and non-inertial frame, okay. We will see these two frames of reference, and there will be 100% coverage of your syllabus. You don't have to worry for it, okay. So thank you very much. Jai Hind, Jai Bharat.